We're continuing on with problem solving and programming techniques. We're on chapter 4, which is lists. In this chapter, we'll define what a list is. We'll talk about how to create one. We'll talk about indexes, nesting lists inside of lists, how to use looping to process a list, and some functions that are included with the list, including random. And then we'll talk about some other sequences at As you can see, a list is an ordered mutable collection of elements. Now that's a lot of words, but basically it means we're going to take data and we're going to put it in a particular order, and mutable means that we can change it. So we can put different types of data inside of a list. We can have integers, strings, floats. We could put bools in there. We could put integers, strings, floats in the same list. So Python's very powerful that way. A lot of languages can't support multiple data types inside of a list. This allows us to put multiple values inside of a single variable. And we're going to have some tools that we can do to be able to sort those lists and be able to walk through them one item at a time. In order to define our list, we're going to use a variable name, the equal sign, just like we would with any variable assignment. But this time we're going to use square brackets, and we'll use commas to separate our values. So you can see in our first example, we have the numbers 1, 2, 3, 4, and 5, and they're going to be inside a list named numbers. And then we can see that we have the mixed data type that has 10 as an integer, hello as a string, 3.14 as a float, and then true for a Boolean value. We can also declare an empty list, which seems kind of silly at the moment, but they're actually quite useful whenever we start doing things inside loops and we need a place to store everything. Now that we have a way to store multiple pieces of data inside of one variable, that's great, but how do we access it? And that's where indexes come in. As you can see, we have a new list that has apple, banana, and cherry inside of it. And I can use what we call an index in order to access different items inside my list by their address. As you can see, I've copied our sample code into a Python file. And we create a variable named myList, and inside of that variable, we put the strings apple, banana, and cherry. Remember, we're using square brackets and commas to separate everything out. As you see, whenever I hover over my list, it specifies that I have a list, and it says it has strings in it. And then I can print by index. So we talked about index real quick, and I mentioned that it was an address. So in most things, we would look and see, okay, I have one thing in my list, 2 things, 3 things. So I have 3 items in my list. So the first item is apple, second is banana, and third is cherry. But as you can see in our comment, and if we run our code, you can see 0 actually prints apple, 1 prints banana. So we don't start counting at 1. As programmers, whenever we're looking at a list, and sometimes in other programming languages, you'll hear it called an array or some other things, but they all have the same concept. We're going to have this is the first item, and we start counting at 0. So this is index 0, index 1, index 2. So I'll go ahead and come in here and add a comment so that we can see. So this 0, 1, so that make this 2. So this is useful because I know exactly where something is. If I add another item onto here, then that would be 3. And I can print by index. Notice here, I changed 1 to blueberry. So if I were to come in after this, let me get some more room. And I were to print my list. I'll just save that. You can see now it says apple, blueberry, and then cherry. If I were to copy my code here, once again, I have to save. Hit the up key to get my previous command. You can see now it prints apple and then blueberry because I have changed what index 1 is. So we can change values. That's because this is mutable. Remember, on the first slide, I said mutable means it can be changed. As we just saw, our list starts with the index of 0 from the left side and counts up by 1. But what happens if I want to count from the right side? So I'm not really worried with what's on the left. I want to start on the right. I can use a -1, and that says start on the right side and start working towards the left. So as you can see here, -1 is the first item counting from the right, which would be cherry. And then -2 would be banana. So let's look at this. We copied over our negative index value example. So you can see I still have the same list, my list with apple, banana, and cherry in it. I left the indexes up here of 0, 1, 2. And instead, I'm now printing my list -1, which starts counting from the right, and then -2, which would go further to the left. So we can go ahead and run this. And you can see it does print cherry and then banana. But before, I was changing my list, and I said 1 equals blueberry. So now I'm counting backwards. Let's see what this does. And this will be -3. My negative sign add an extra space. But there we go. So I'm going to see if I can access this using a negative number. And then I will print my list, -2. Save that. And you can see it did update blueberry in my list in the -2 position. So I can use negative numbers to count from the right, starting at -1, or I can count from the left using 0, 1, 2. So that's the indexes. As I mentioned earlier, we can put lots of things inside the list. We can put strings, int, float, bool. We can also put other lists. So when we put lists inside of lists, we call these nested lists. And we're going to access them using the indexes. And the first index that we access is going to get us the list out of our list of lists. And then the second index will reference inside of the list. We need to be careful whenever we use nested lists because obviously this can get really confusing really fast. Also, putting list inside a list is a lot like putting loops inside of loops inside of loops. It grows exponentially. So if you use nested lists and you let it get out of hand, it can cause memory issues and performance issues. Once again, I've copied our sample code over. You can see I have the nested list variable, and I'm declaring a list. So I have the square bracket, and then inside of that, I have another list because I have square brackets and there are commas inside separating out things. So I have a list 1, 2, 3, and that is the first element inside of my nested list. Then the second list is 4, 5, 6. And then the third list is 7, 8, 9. Now notice, I don't have a comma on the end of this last one. If I had a comma here, it would cause issues. So when I call print, you can see I have nested list and it says index 0, but we know index 0 is the first item in our list. So I look at nested list, and I have 3 lists inside of nested list. So this is the first item. So this is going to be index 0. So when I run this, I'll go ahead and comment out this second print. You will see it prints 1, 2, 3, which is the first list, so index 0. For our second print statement, we have nested list, we have index 1. Well, index 1 is actually the second list inside of nested list. And then inside of that, we're going to look for index 2. So that you would think would be 5, but it's not, because remember, we start at 0, so 0, 1, 2, so it's actually 6. So index 1 goes to the second item in nested list, which is this list. Then index 2 goes inside of here to the third item. It takes a while to get used to. Once you get used to it, it'll become second nature. But we're just starting to count with 0, so it makes the second thing index 1, the third thing index 2. So if we save this, and then I hit my up key, rerun it, you can see I do get 6. So I want you to think for a minute, how would you get the 8? And you can hit pause if you want to. So for our first number, we need to go down. This is 0, 1, 2. So I need to print 2. And then I was going 8. So now 0, 1, 2. So 8 is index 1. So I will get rid of that. I will save. And then I'm going to clear my PowerShell. And then I can hit up twice in order to get to my Python executable command for this Python file. And you can see I do get 8 because I went to my inner list and found the list I was looking for. And then I found the number I was looking for inside of there. Now, we could have a list inside of this list, and you will do that at some point if you continue on software development. But really, this is just the concept that you need to know, and this is called two-dimensional. So sometimes you'll hear a two-dimensional array or a two-dimensional list. That means I have a list inside of a list. If I had another list that each one of these held another list, then that would be 3 dimensions. So however deep you go, that's how many dimensions you have. I know people that have gone 10 dimensions deep, and then they ate up all the RAM in their computer and it crashed the program. But you can, in theory, do that. The question is, does it solve the problem that you're trying to solve? Now that we have all of our data stored under one variable, we want to be able to access that data. And the easiest way to get to everything in our list is to use the for loop. we do have while loops and you can make it work, but while loops traditionally are when we have the user needs to change something in order to get us out of the loop, like we've seen with validation. A for loop is, I know exactly how many times I need to go through this. So it's a lot more specific. It's when we know the length of our list, which obviously we're going to know because we're putting stuff in it, or we just want to iterate through all of it. So you can see we have a for, fruit, and fruit. So it's kind of, sometimes you'll hear this as a for each in other languages. So for each fruit in my list fruit, we're going to print fruit. And then below that, you see we can also use a range if we want to get our indexes. So let's take a look at this in code. As you can see, I've copied the code over from the slides. Notice that we have fruit is plural. So whenever you're storing a list, it's best practice to use the plural variable name, especially if you're going to want to loop over it with the for loop like we show here, because I'm looking in fruit. So I'm going to go to every value that is a fruit. So my instance variable will be called fruit, and it is one instance in the fruit list. It's a small detail, but it makes it easier whenever you're reading through your code. So I have for fruit in fruit, so I'm going to print each fruit. We can run the code and see that that's what it does. Now at the same time, I've commented out the second loop. So let's add it in. I'm going to save. And you can see this one uses a range. So this is if I want to get the index. Now, remember, when we're working with a range, it returns numbers, and if we only give one value, it goes from 0 to whatever that value is, but it's a less than. So it will not use, in this instance, 3. So when I go through my range, it's going to start counting at 0. So I'll get 0, 1, 2. So that will cover the 3 values. So I'm using length of fruit, which is 3. So this will return 0, 1, 2. So when we print it out, we'll get our index. So let's go ahead and run it. So you can see this is a way to get the index and the value that is associated with it. The list gives us many functions that we can use. They're built into Python. So you can see we have mylist.append. This is if we want to add something to our list. So, for example, we had fruit just a few seconds ago. So if I said fruit.append blueberries or pineapple, then that would just add it onto my list. I don't have to reassign it with the equal sign. It's just going to add it right in, and it's simple. On the other hand, you see length, that returns the length of the list. So that's going to return an integer. In that last loop that we had, we used length to find out how long our fruits list was. So that returned an integer that we could use. Minimum and maximum, these are very standard with lists in other programming languages and databases. So this will give you the minimum value and the maximum value. Now realize whenever you're dealing with mixed lists, so strings and integers, you might get some interesting stuff on which one is minimum and which one is maximum. Sum is going to add up everything in your list, and sorted, it's going to sort that list, and realize all these return, so you're going to need to load them into a variable, or they can be arguments that are passed into functions, but they're returning a value. And then finally, we have random choice, which I have to import random for that one, and we're passing the list in as a parameter to this function choice. So we'll take a look at how that one works. because it's a little bit different. We have to import random, but this one is very useful whenever we're trying to get a random item out of our list. Here you can see I've written some code that's going to demonstrate some of the functions that we were just looking at. I still have my fruits list, and I'm going to print before, and I'm going to use that for loop that we looked at earlier to print each of the fruits that is in the fruits list. Then I'm going to append pineapple, and you can see that it will be added on, and then we'll use random.choice to get a random fruit from our list of then 4 fruits. So let's go ahead and run this. And you can see it says before, so that's line 4. And it says apple, banana, cherry. So that's going through my first list. And then we have after, then I have apple, banana, cherry, pineapple. And my random fruit is cherry. And I'll hit the up key and we'll run this again. And now you can see my random fruit is banana and cherry. Now, I've had a lot of banana, I've had a lot of cherry. That's not a flaw in the random system. It's just a matter of each time it's a 1 in 4 chance. So it just happens to be that. Now, we don't base things that require random off from the Python random library, but for the purposes of this, it's operating as I would expect it to. So there's the apple. So this is very useful. A lot of people will try to use random in order to get random integer within a certain range, and then they'll use that integer in order to get the index to find stuff in here. That's complicated. It works. That's actually probably how random.choice works, but somebody with Python wrote that. So let's take advantage of it because they've written it, they've tested it, and we know this works the way it needs to work. So if we're trying to get a random item from a list, random.choice is your friend. We do have some other sequences. Typically, lists are going to be the most popular. We do have tuples. Remember, we can change what is in a list. A tuple is immutable. Immutable means it can't be changed. So think list, except it is locked in. We're going to use parentheses instead of the square brackets. Now, when you're accessing it by index, you will use your square bracket in order to specify what the index is that you're looking at. So you can see that here with my tuple, index 1 is Barry. So I'm trying to reassign that. This will actually throw an error message because the tuple can't be changed. Tuples are kind of a newer concept. They're faster than lists because you don't have to worry about things changing as you're working with it. Immutable became a big thing whenever we started getting processors that had multiple cores, hyper-threading, and we could start farming out logic to different processors at the same time. Well, if I want 5 people to work on one project real quick, I need to make sure that the rules of the project aren't changing while they're working on stuff and they show up with something and it's no longer relevant. So being able to make something immutable means that the job can't change until everybody's done with their part. So that's where tuples came in. Also strings. So apple is a string. It's a string of characters. Well, these are tuples. Technically, they're not tuples, but they act like tuples, and we can treat them like tuples. So you can see on the bottom line, it says print my string 1. Well, H is the first letter in the string, so that's index 0. So index 1 is E. So strings are going to act different, but they're still sequences. They're in order. We can have duplicates. So apple has 2 P's in it. Barry has 2 R's. So we're going to look at strings a lot like tuples, because when you change a string, it's going to actually create a new string instead of just adding to it or adjusting it like we would with the list. So that is the end of chapter 4. So we've talked about what a list is, how to create one, how to access a sequence value by index, how we can put sequences inside of sequences, looping. So we can loop over a tuple or a string just like we would a list using the for loop. We've talked about some of the functions, and also we did cover other sequences.